Hello everyone. Welcome to the course Python Programming for Beginners. In this lecture, with continuation of NumPy, here we will discuss about the next concept related to NumPy, basic operations using NumPy. Okay, as part of basic operations, first we will see some of the arithmetic operators. So what are the arithmetic operators and how to apply on arrays? Arithmetic operators on arrays apply element-wise. In the array, each element, you can apply arithmetic operations between the elements of the array. So whenever a new array is created and filled with the result of the arithmetic operator used. Okay, let us see one simple example. First, you can import NumPy array, import NumPy as NP. Now, you are creating one array, NP dot array of with the elements 10, 20, 30, 40. That is stored in A, array A. Then another array with the elements 4 with 0 to 3. That is stored in B. B equal to NP dot A range of 4. Now, what B contains 0, 1, 2, 3, 4. Now, you want to perform some arithmetic operations on array A and B. So, what are the arithmetic operators you are having? Generally, you are having plus, means addition. Then you are having minus. Minus means that is subtraction. Minus operation. So minus is the subtraction. Then you are having into multiplication, etc. So you have to apply on array A and B with these arithmetic operators. Let us see how this can be done. Okay, the first program, here you can see whatever the arrays we created, A and B with these elements. So let us see C equal to A minus B. So here what A contains, A equal to, if you want, clearly you can write down 10, 20, 30, 40. Then what B contains 0, 1, 2, 3. Now what we are doing here first, A minus B. That means 10 minus 0, comma, this one minus this one. 20 minus 1, comma, 30 minus 2, comma, 40 minus 3. What you will get here? 10 minus 0, 10, comma, 20 minus 1, 19, 30 minus 2, 28, 40 minus 3, 37. This is the result which can be stored in C. Let us see here. Whenever you can print C, A minus B, 10, 19, 28, 37. This is the result. Similarly, D equal to A plus B. So here, D equal to A, 10 plus 0, 10. Next, 20 plus 1, 21. 30 plus 2, 32. 40 plus 3, 43. This is addition. Here you can say D equal to A plus B. 10, 21, 32, 43. Like that you can perform addition operation. Okay, let us first see these programs lively by demonstrating. Here you can see first here create one array that can be stored in A. Open your Python ideally. Now here you can see you are getting some error. What is the error? Let us see. Here first time we open Python ideally. First we have to import. If you want to import NumPy, you will get error. So NumPy, import NumPy as NP. Now you can here why, because you called NP object, but without importing, how it will work. Now we can import. We imported NP. Now you can see. Now array A is created. Now we can call A. Yeah, this is the array 10, 20, 30, 40. Similarly, take another array B with 4 elements with the range 0 to 4. Now you can call B. Here you can see. So now you are printing addition of two arrays. C equal to A plus B. Now you can call C. See the result. So 10 plus 0, 10, 20 plus 1, 21, 30 plus 2, 32, 40 plus 3, 43. So this is addition of two arrays. So now here you can see how the operations are performing. Whatever the arithmetic operator we are using, that is performed element-wise in both arrays. In both arrays. See, in both arrays, the number of elements should be the same, the count. Then only it performs equally on each pair. The respective arithmetic operators are performed. Similarly, you want to perform addition. D equal to A minus B. Now the result is stored in D. Now let us see D. Here you can see A means first element is 10. In B first element 0. 10 minus 0, 10. In A second element 20. In B second element 1. 20 minus 1, 19. Then in A third element is 30. In B third element is 2. 30 minus 2, 28. In A first element is 40. In B second element is 3. 40 minus 3, 37. This is the subtraction of two arrays. Now C is the addition of two arrays. So element wise, the operations are performed. Similarly, next you can see you want to perform some more operations. So here you can see we are taking AB. Suppose on B you want to apply power operation. So B power 2. This is nothing but power. Here let us write clearly B equal to 0, 1, 2, 3. Now B power 2, nothing but B square equal to 0 power 2, 1 power 2, 2 power 2, 3 power 2. Then what is the result? You will get 0 power 2, 0, 1 power 2, 1, 2 power 2, 4, 3 power 3, 9. So this is the resultant array you will get 0, 1, 4, 9. Here you can see 0, 1, 4, 9. That is the power operation. Similarly, you can use some inbuilt functions also. For example, here the sine function is used here. Trigonometric functions, sine function. So here 10 into np dot sine of a. Here a means the array a 10, 20, 30, 40. First it find sine values of array a. That means sine 10 first value, sine 20, then sine 30, sine 40. The result is multiplied with 10. Okay, now find the result is, here you can see minus 5.44, 9.121, minus 9.88, 7.45. So whatever the sine values of a, those resultant values are multiplied with 10. So like that you can perform. Let us demonstrate this. Go to your Python. Here what you have done. So b power 2. You can call array b here once again. So this is the array b. Now b power 2. What you will get? The every element in b, that is taking the power value with power 2. 0 power 2, 0, 0, 1 power 2, 1, 2 power 2, 4, 3 power 3, 9. The next one, suppose you want to multiply 10 into np dot some trigonometry function, sine of A, sine of array A. And this is the result you will get. The same thing, suppose you can apply for array B also, 10 into np of sine of B. Here you can see. First you can find sine of each element in array B. The resultant value is multiplied with 10. Then this is the resultant array. Like that you can perform any arithmetic type operations on array elements. Those can be executed element wise, the operations. Next, even you can perform some relational operators also. So what relational operators produces? Based on the condition, it displays the Boolean values, true or false. So the same array you can take A 10, 20, 30, 40, then B 0, 1, 2, 3. So now you are applying some relational operators. For example, the first one is A less than 30. Here what is A? Clearly you can write down A equal to 10, 20, 30, 40. Now A less than 30, you can verify the condition. First 10 less than 30, comma 20 less than 30, comma 30 less than 30, comma 40 less than 30. Which are true, which are false, you can check. The first one is 10 less than true, 20 less than 30 true. Next 30 less than 30, actually this is equal, so this is false. Then 40 less than 30, this is also false. What you will get? True, true, false, false. This is the result. Here you can see A less than 30. True, true, false, false. Similarly, A greater than 30. You can verify 10 greater than 30. Then 20 greater than 30, 30 greater than 30, 40 greater than 30. So what is the result you will get? False, 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 true. So like that, you can verify the relational operators also on arrays. Okay, before moving to next operation, so let us check these also. Okay, now your array A, suppose A less than 30. Let us see. A less than 30, array of true, true, false, false. Similarly, A greater than 30. False, 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 true. So like that you can check the relational operators also on arrays. Now the next operator, the product operator, which is denoted with star. Here we have different purposes. So the product operator star operates element wise whenever you are using NumPy with arrays. The matrix product can be performed using the @ operator in Python, the versions 3.5 and above, or the dot function, or the method. Let us see all these possibilities. So first you can take the array with two-dimensional array A equal to like a matrix format 1 1 comma 0 1. Then B equal to with other elements with 2 by 2 matrix 2 0 3 4. Here you can see A equal to 1 1 0 1. This is like matrix. Here commas also not required. B equal to 2 0 3 4. Both are 2 by 2 matrices. So you want to compute the product operator star in NumPy, then the matrix product using @ operator, or the dot operator, dot function or method. Let us see all these with examples. First you can see whenever you can use NumPy, product wise, element wise product. For that we will use star A into B. That means element wise product. Here you can take again A equal to 1 1 0 1. Here you can write clearly A equal to 1 1 0 1 1 1 0 1, B equal to 2 0 3 4, B equal to 2 0 3 4, 2 0 3 4. So here A into B with the product operator star equal to element-wise multiplication. The order is same for both matrices 2 by 2, 2 by 2. Each element can be multiplied in both arrays. Now arrays here now matrices, two-dimensional array. So first matrix, first element is 1. Second matrix, first element is 2. So here you will get 1 into 2. Then the second element in A 1. Then second element in B is 0. That is 1 into 0. The same corresponding values. Then the next element, second row, first element is 0 in A. Then the second matrix, the second row, first element is 3, 0 into 3. Then the first matrix, second row, second element is 1 into the second matrix, second row, second element is 4. What we will get? 1 into 2, 2, 1 into 0, 0, 0 into 3, 0, 1 into 4, 4. What we will get? 2, 0, 0, 4. This is the product operator in NumPy, that is element-wise product. If you can take matrix product, then you can use at the rate symbol. A at the rate B. Now you can see this is matrix multiplication. You know the matrix multiplication, how to do in mathematics, the same. Here you will get 5, 4, 3, 4. The same in place of at the rate, you can use the dot method. A dot dot of B is another matrix product which gives the same result. So that is A at the rate B equal to A dot of B using the dot method. So both cases, here what is the operation? Matrix multiplication operation. If you can use star, that is element-wise product operation. Let us execute this program. Here you can see all this we already completed. Now product operator we already imported. Suppose first create a matrix A. Here you can see. We can call A. Yeah, this is array A. Then create array B. B equal to np dot array of 2034. Now we can call B. Now we can see. First, let us see element-wise product. What we can do using into operator star. A into B. Here you can see. A into B. 2004. Whatever we have demonstrated theoretically. This is the output. Similarly, you want to compute like matrix multiplication. You can use the at the rate symbol. A at the rate B. Now you can see this is the matrix multiplication result. But matrix multiplication, the matrices order m by n, n by p. In first matrix, n. In the second matrix, n. n by m. m by n, n by m. Should be matched. That is the condition of matrix multiplication. Here you can see, suppose two matrices you are having. The first matrix A with m by n order. The second matrix B with n by p. In first matrix, number of columns should be matched with the second matrix number of rows. This is the condition. So then the output matrix order is m by p. So this is the condition of matrix multiplication. Okay, now the same, how to do this one? Using the dot operator, A dot, using the dot function, dot of the second matrix. Here you can see the same result you will get. using the dot method or a function. A dot of the second matrix is B. So like that you can perform matrix multiplication, normal element-wise product of the two array type matrices. Okay, now like that you can perform some more operations like here you can see plus equal with assignment arithmetic operators, then multiplication equal. So act in place to modify an existing array rather than creating a new one. So using these arithmetic assignment operators, which will act in place to modify an existing array instead of creating a new one. Let us see, for example, import NumPy as NP. Now you are creating some random numbers that can be stored in RG equal to np dot random dot default underscore RNG of 1. Here RNG is the random number generator. Create instance of default random number generator. Now another array with 2 comma 3 with the type integer 2 by 2 by 3 matrix with 1 filled with 1 that is stored in A equal to np dot ones of 2 comma 3. We are taking integer type. Now the other result is 2 by 3 dimensionality, 2 rows, 3 columns filled with 1. Now B is another matrix that is creating with the random number generators, random number values. In B, that is the maximum value is 1 means less than 1 only, all that values. So that is stored in B. B equal to RG dot random. Here what is RG? It takes the random number generated less than 1. Here you can say B equal to RG dot random of with 2 by 3 matrix, 2 rows, then 3 columns. All the values you can see random numbers. So all are in the range of less than 1 only. Why? Because we have given the end value is 1. So before 1, it displays all the random numbers with 2 by 3. Now A matrix with all ones 2 by 3. Then B matrix is also 2 by 3. Here you can see 2 rows, 3 columns. The dimensionality of both matrices are same here. Now let us perform some operations here. Here you can see first we are performing what is the operation here? A into equal to 3. So what is the meaning of this? A into equal to 3. The matrix A, each element in the matrix A that is multiplied with 3. Now actually what is 1 here? 1, 1, 1, 1. This is 2 by 3. Now A into equal to 3 means A into 3 that equal to 1 into 3, 1 into 3, 1 into 3. Then 1 into 3, 1 into 3, 1 into 3. What will get? 3, 3, 3, 3, 3, 3. Element wise, it multiplies with 3. That arithmetic assignment operators. So this is the output we will get here. Similarly, another example, suppose B plus equal to A. B plus equal to A. That means the array B that can be added with A. Here nothing but B equal to B plus A. What is meaning of this? B equal to B plus A. So the array B added with A. Now this is A. What is B here? 0.51, 0.95 and so on. So for this the new A 3. 3 plus 0.51, what will get? 3.51. Next 0.95 plus 3, 3.95, like that. So you will get this one. The same thing if we can do in the reverse order. Here you can see A plus equal to B. That means A equal to A plus B. So actually, what is A? A is of integer type, B is of floating point type. So whenever you can perform this operation, it is not automatically converted to integer type. Why? Because here A equal to A plus B, A is of integer type. It won't convert automatically with integer type. That's why here you will get error. Okay, let us run all these examples. Let us observe the output. So here what we have explained. So this multiplication is over. Now first random number generator RG equal to take RG. Here you can see using this RG create one new array. First create one array A with 2 by 3. Now if you can call A, let us see. A contains 2 by 3 with filled with all ones. Then B you can create with using RG with 2 by 3 dimensionality. Here you can see the random numbers with less than 1. Now 0.51, 0.9, 0.1, 0.94, 0.31, 0.42 and so on. Now here what are the operations we performed? First A into equal to 3. Now the result is stored in A. Earlier A what it contains 2 by 3 filled with 1s. Now that is multiplied with 3. Now all are 3 with. Now you can see this is the result. Now whenever you can call A, now onwards, it calls the recent updated values only. That is all 3s. Similarly, B equal to B plus A. The result is stored in B. Now you can call B. Earlier B what it contains 0.51, 0.95 and so on. Now you can see after performing this operation, 3 is added to each and every element in B. 3.51, 3.95 and so on. Now onwards, B uses the latest updated array only. So if we can perform in the reverse order, just now we mentioned, here you can see what you will get, you will get error. Automatically it won't convert. So automatic conversion is not possible. Why? Because floating point to integer. So these are some more operations. Okay, now we'll move to some other operations operating arrays of different types. For example, here you can see arrays of different types. The type of the resulting array corresponding to the more general or precise one. So this behavior is called as upcasting. So whenever you can take different arrays, then the result which is corresponding to more general or precise one. That behavior is called as upcasting. So let us see one example here. For example, here import NumPy as NP, then import math module. That means by using some mathematical built-in functions. So here, first one array is creating array A equal to np dot ones filled with 1. So total 3 elements, normal one dimensional with array type int 32. Now whenever you can call A, what A contains 1, 1, 1, 3 elements. Okay, now if you want to check the type of array A, we have the method dtype. Array dot dtype dot name. If you can use this method, the type is displayed int 32. Okay, this is one array. Next, another array with linear space you are using b equal to np dot lin space 0, comma, you are using the math pi value, math dot pi, comma 3. Now you can see starting with 0, then end with up to 3 values. Then next value is increment value is this one. So 1.571 math dot pi, then 3.14. So this is array B. If you want to see its type, what values it contains, floating point. B dot D type dot name equal to float. Now, whenever you can perform the addition of the two arrays, previous one array is with the type integer, then array B is type floating point. Now you are adding integer to floating point. That result is stored in C equal to A plus B. So what is the result here? Integer plus floating point addition, you will get floating point only. Here you can see. So first what you are having 1 plus 0 0.0, that means 1 point. Then 1 plus 1.5, 2.57. Then 1 plus 3.14, 4.14. Now you can see the resultant array type. What is the type here? Floating point. You want to check C dot D type dot name. Says float type. Similarly, another example, if we can use the complex data type. For example, D equal to np dot exponent exv of C into 1j. Here 1j is the complex value type. Now the resultant of D is array of 0.54 plus means power 0.814j. This is like uh, I plus j, real part and imaginary part. So after plus you can see with j is there, imaginary part, real and imaginary combination. See, all are complex numbers here now. Now if you want to check the type of D dot D type dot name, what is the type here? Complex. So like that, arrays with different types. Also you can perform the operations. So if you want to check lively, let us see. So here what you have done. So here additional you can import math. Why? Because first time we are using means you have to import. Now create array A with ones, all are ones, 3 elements. Next, if you want to see the type of A dot D type dot name, that is integer type. Then create another array P with linear values with range. Start value is 0, then math.py, then step value is 3. Now you can call B. This is the array B. Now you want to see the type of array B dot D type dot name. What is the type of values it contains? Floating point. So its type is float. Then you want to add the two arrays A plus B, C equal to A plus B. Here you can see A contains integer values, B contains floating point values. Then what is the C resultant array? You can see C contains floating point values. You want to check the type of elements occurred in C dot D type dot name. Here you can see what is the type of C, floating point. Similarly, if you can use complex values, for example, D equal to np dot exponent of C into 1j. Now you can see D, what D contains complex values. You want to see the type of array D. So D dot D type dot name. What is the type here? Complex. Okay, like that you can perform the basic operations on arrays with different types also. Now there are some unary operations also. So using some built-in functions. So many unary operations such as computing the sum of all the elements in the array are implemented as the methods of n-dimensional array class. For example, you can see import NumPy as np, a equal to rg dot random of 2, 3. Earlier we have seen. Now we are using unary by using some inbuilt functions. A dot sum. All the elements in A are added. Then the result is this one. single value 3.10 and so on. Then out of A, you want to find the minimum value, A dot min. Min is the built-in function. SUM is the built-in function. It displays the minimum value. Then A dot max, maximum value. So let us see this one. First, A equal to RG dot random of 2, 3. Let us see that matrix A first array. Now you can see this is A. Now what we are doing? Some unary functions you are applying. The first one is A dot sum. A dot sum. Without passing any value inside the function. Simply you can see. Now A dot sum means all the elements in array are added. That is 0.8 plus 0.4 plus 0.5 plus 0.02 plus 0.75 plus 0.15. So all these elements summation. What is the result you will get? The single value is displayed, the total of all the elements, 3.10 and so on. Similarly, the next function is minimum. So the function is min, a dot min. From the array A, what is the minimum value? 0.8, 0.4, 0.54, 0.02, 0.75, 0.53. See, 0.027 is the minimum value. Here you can see the output is same. Similarly, maximum value, if you want to find maximum value, what is the maximum value here out of 6? 0.8 is the maximum value. Here you can see 0.827. This is the maximum value. Like that, you can find the resultant values by applying some unary operations like sum, min, max, average, etc. And also, by default, these operations apply to the array as though it were a list of numbers, regardless of its shape. However, by specifying the axis parameter, we can apply an operation along the specified axis of an array. Let us see one example for this. So first import NumPy as NP, then an array B equal to NP dot A range with 12 elements with reshape 3 by 4 dimensionality, 3 rows, 4 columns, 0, 1 to 11. That is one array. Then another array. Now you see you are performing some operations based on axis. First, the sum, same as previous example, what we demonstrated. So here, B dot sum of axis equal to 0. So 0 means what operation it performs by default? Sum of each column. So each column sum the resultant value. So 0 plus 4 plus 8, 12. So here array of 12. Then next column sum. 1 plus 5, 6 plus 5, 9, 15. Next third column 2 plus 6, 8 plus 10, 18. Next column 3 plus 7, 10 plus 11, 21. You can see sum of each column. Axis 0 means, what is axis 0? Column wise. Then similarly, if you can take axis 1, that means row wise. Row wise, it performs. Suppose here row wise minimum value, p dot min of axis equal to 1. So each row, you can see the first row minimum value is 0, here 0. Second row, 4, 5, 6, 7, minimum value is 4, 4. Third row, 8, 9, 10, 11, minimum value is 8. So it performs according to row wise operation if axis is 1. If axis equal to 0, it performs according to column wise, whatever the operations we are using. Then even if you want to find cumulative sum, the method is sum. Suppose you want to find row wise cumulative sum, you can use axis equal to 1. Cumulative sum along with each row. So row wise cumulative sum. So 0 plus 1, 1, then 1 plus 2, 3, then 3 plus 3, 6, like that, cumulative sum. So this is sum. So let us demonstrate this one. What was the example? First here B equal to NP dot A range of 12 with the reshape of 3 by 4 dimensionality. This is array B. Then you are performing according to axis 0. That means column wise some values. B dot sum of axis equal to 0. So then column wise all the values are added. Then again it prints like a one dimensional array according to the result of each column value summation. Similarly, according to row wise, if you want to apply any function, suppose b dot min of axis equal to 1. So according to row wise, each row it finds what is the minimum value. Here you can see 0, 4, 8 are the lowest values. Similarly, if you want to find cumulative sum according to row or column, just you can mention the axis. Suppose axis 1 equal to axis equal to 1 means that is according to row. Row wise it finds the cumulative sum. That is 0, 1, 3, 6, 4, 9, 15, 22, 8, 17, 27, 38. Okay, these are all some of the basic operations on arrays using NumPy. In next lecture, we will come up with other new topics related to NumPy. Till then, stay tuned for latest updates.